Good morning, dear students. Uh, we will be recording this session today and will be kept in the Google Classroom for the students who are not able to join online. First, let me present what we have discussed in the last session. Then we will come to the today's session. Right, last session we have talked about the course outline completely, in the sense what topics we are going to discuss in this pre-stressed concrete, and course outcomes, how they are written by modifying the course outcomes given by JNTUK, and program outcomes, how they have been written given by the NBA, and how course outcomes are mapped to program outcomes, and course end survey, uh, how the course end survey form will be and what does it represent. So all these things I have explained in detail in the last session. I'll just run through the slides, what happened in the last session for those who missed the last session online. So these are the regulations, R16 regulations given by JNTUK. It's available online in the JNTU site as well as your handout. And when it comes to the syllabus, pre-stressed concrete has got 6 units. First unit is going to deal with the introductory content, also the materials required for pre-stressing, and unit 2, the pre-stressing systems, to discuss, and also to discuss about the analysis. And unit 3 will be losses, unit 4 bending design, and unit 5 shear and torsion design for pre-stressing, and unit 6 will be completely to talk about end zone. The textbooks that you have to follow, which are prescribed by JNTUK Kakinada, is Krishnaraju and Ramamritam. There are reference books also for your reference, Dayaratnam and Lin and Burns. So these are the course outcomes which I have explained you in the last session. So CO1, what student will be able to do after undergoing this course. Okay, so CO1, CO2, 3, 4, 5, 6 are written, and program outcomes are given by NBA, National Board of Accreditation, and program specific outcomes are specific to the branch or a program called civil engineering, and program educational objectives are also pertaining to a particular branch, what student will be able to do after his graduation, maybe 2 to 3 years after his graduation. And there will be mapping how each course outcome is linked or mapped to the program outcome, what is specified by NBA, AICTE. So how each course and the course outcome contribute to your program outcomes. This table shows that one. There will be course end survey form given to you, and this will be taken up in the computer center uh, by online mode. This form will be available to you in the online mode, and you will be filling this form at the end of the course. Okay. So this is what is discussed in the last session, and now we will move on to the content that is to be discussed uh, in this session now. So let me present Unit 1 to you. So we will be starting with Unit 1 content. So, so what is in Unit 1 of prestressed concrete is to talk about basic concepts of prestressing. We'll be talking about basic concepts of prestressing, and we'll talk about advantages and applications of prestressed concrete, and we'll talk about high strength concrete and its properties in detail, and we'll talk about high strength steel uh, and its properties in detail, right? So this is the Unit 1 content. So we'll be talking about basic concepts in pre-stressing, and the advantages, applications, and high strength concrete and high strength steel, which means the material required for pre-stressed concrete. So we'll come to the first topic of pre-stressed concrete, which is basic concept. What is the concept behind this pre-stressed concrete? Pre-stressed concrete structure is definitely different from the conventional concrete. Okay, so if you take a conventional concrete structure, we will be reinforcing the steel, which is uh, maybe a grade of 250 steel, or a grade of 415 steel, or maybe 450 or 500 or 550 at the maximum, which is available as of now. Okay, so this is what a conventional reinforced concrete structure is actually. Okay, so it is completely different from that. A pre-stressed concrete structure is completely different. How it is different? So the difference is application of an initial load on the structure prior to its use. This is the difference. So a conventional reinforced concrete structure, we will build the concrete structure, and then it starts taking the load. Like during construction, it may be the after completion of construction, just self weight is the load that is going to be taken by the structure, and after completion of the structure construction, then the live loads will come into picture, and slowly it starts taking the live loads. This is what is the regular conventional reinforced concrete structure. Uh, in case of pre-stressed concrete structure, before even before its use, so it is going to take some load. So that is what is pre, means before actually uh, to come to its use. Okay, so this is what does it. It is made different from the conventional structure, RCC structure and PSC structure. Okay, right. Initial load or pre-stress, what we call is pre-stress, earlier stress before. Okay, is applied to enable the structure to counteract stresses arising due to its service period. Means, for example, if a conventional RCC structure is built and we know what type of stress it is going to receive in case of the regular loads that we estimate. So if you just say a column, so column is going to take majorly compression, okay, and a beam is going to take majorly the bending, and in turn compressive stress and tensile stress. So these are the things that we estimate. If you induce or develop pre-stress, a stress which is opposite to the expected stress in its service period, then that what we call is pre-stress or initial load. Okay, so that makes the structure to counteract for the stresses to come in its service period. For example, if a cantilever beam is there, so we expect the top surface of the beam is to have tensile stress. So if you develop a compressive stress before the tensile stress come, then both are opposite in nature. So the net stress, you can make it nullify, or net stress you can make it to lower level, reduce to the lower level. So that is what is the the enabling the structure to counteract means. Okay, and in fact the concept of pre-stressing existed even before the concrete applications. Even you don't have a concrete structure, even before that also there is pre-stressing existed. Okay, so some examples we will be discussing how this pre-stressing was there even before the concrete is used. Okay, so the basic concept overall is to induce some stress to counteract the stresses arising during its service period. This is a basic concept involved in this one. Right. So this is the one example where the barrels, wooden barrels, you might have seen in some of the Hollywood movies, that the wooden barrels are used to store the material, maybe liquid or maybe the powder form material, sometimes gunpowder and all, in case of ships. Okay, so these wooden barrels, how they are made to leak proof. Okay, so if imagine a wooden barrel carrying some water, how you prevent the leakage. Okay, so this main concept behind this is to introduce metal bands around the wooden planks. Okay, what that metal bands would do means force fitting of them. uh, what it will do, it will generate initial hoop compression. And you know, from the strength of materials concept, that pressure vessels. Okay, so hoop tension is very common in case of pressure vessels. So to counteract the hoop tension, we need to induce hoop compression. So the hoop tension will try to split apart the wooden planks, and that is possible for leakage of the liquid or the mineral, I mean powdered form material. So to not to have the hoop tension, what you need? hoop compression. So that is done by this metal bands to fit the metal bands forcefully onto the circumference of this wooden barrels. Okay, so this is for filling of liquids or maybe the powdered form of fine powdered form of materials. Okay, this is one good example. And another example of a daily life is a bicycle wheel. That everybody knows that a bicycle wheel. Uh, what does a bicycle wheel spoke? The fine diameter rods are called spokes. So a spoke of a bicycle will come across when you ride the bicycle. The load that comes onto the spoke is compression. So because of the compression, as it is very slender in nature, means small in diameter, big in larger in length, so it is very slender. So it can't take any compression at all. So what do you need to do then? You need to induce some tension so that it takes care of the compression that comes when you ride the bicycle. Means when a compressive load is coming onto it. So that is the purpose of inducing this pre-tension in the spokes of a bicycle wheel. Okay, so that is done by by just screwing it. The spokes will be screwed into this rim, outer rim, so that you will pull the spoke and by screwing the spoke into the rim, the threads provided to the rim, right? So that you will be, when you visit the shop, bicycle repair shop, so there they'll be doing that. So whenever you feel that your spoke is loosened, then you take your bicycle to the shop, and what he will do, he'll take an instrument, and then he will just screw it up to tighten the spoke, which means he induces tension so that what happens if there is no tension available in the spoke, it can't take the compression, hence the problem is for the rim. So you will have local uh, uh, bending of the rim. Okay, so that is a problem. So only when this is having the tension, that prevents the rim to not to damage. Okay, and this is one another good example of pre-tension. Okay, where here you are going to induce pre-compression. Hook compression you are inducing, and the second example, you are inducing pre-tension. And another very good example is the shrink fitting of metal bands on wooden rim of a bullock cart wheel. This, if you have come from a village, you can see this very frequently. How this is made, the bullock cart wheel is made by the wooden hub, and the wooden hub will have the spokes, wooden spokes. Then wooden spokes are fitted to the felloes, means the parts of outer rim, wooden outer rim. This is not a single uh, like at a stretch it cannot be made. Full round circle cannot be made, so they'll make it in terms of parts. Those are called fellows. So each part will have spokes attached to it. Then finally, this outer black colored thing that you see is the metal band that will be Actually, if it is now in cooler state, it will have lesser dia than this outer dia of this wooden fellow. Hence you cannot fit it. So what we will do, we will heat this metal band, then fit it, pull it, so it will induce now hoop compression again, the same concept. Okay, so the tension caused by the load will be in this fellows will be counteracted by hoop compression induced by this metal band, which is cooled, I mean heated, force fitted. That is what is called shrink fitting. Okay, so you heat it, fit it, and then cool it, called shrink fitting. Okay, so these are some of the examples which are existed well before concrete is used. Okay, so this is how the pre-stressed pre-stressing concept is available, right? So for concrete, internal stresses are induced usually by means of tension steel, uh, because of the following reasons. So why we are using steel, tension steel in the concrete? Because tensile strength of concrete is only about 8 to 14% of its compressive strength. Uh, that is one good reason. And cracks tend to develop at early stages of loading in flexural members such as beams and slabs is another reason. To prevent such cracks, compressive force can be suitably applied in the perpendicular direction. This is the another reason for pre-tensioned steel. Pre-stressing enhances the bending, shear, torsional capabilities of flexural members, and in pipes and liquid storage tanks, the hoop tensile stresses can be effectively counteracted by circular pre-stressing, and we'll talk in detail about this also. So these are the prime reasons for inducing initial, I mean, internal stresses. Okay, to have the enhanced lifetime of the structure or the structural member. Okay, so this is about the basic concept and some examples for this pre-stressing, how it is being done even before the times of concrete, right? Okay, thank you all for the attending the session, and I'll make this class available in the Google Classroom. I'll put this recording in the Google Classroom also.